Well, good morning, everyone. My name's Andrew Preston, and I'm presenting today so you want to be a data scientist, or at least understand what one does. So let's hop into it. I've got a little background about me. I'm a managing director with Infosemantics. We do a lot of work in the ERP space, the Oracle ERP space, but I really focus more on data warehousing and financial reporting off of Oracle ERP for large systems. So I spent 25 years working in IT consulting, a lot of data focused systems, most custom programming's around data at some point. A lot of IT projects wind up working with data. I chair the Northwest Oracle User Group here in Portland and also Seattle. I've been privileged enough to work with data science projects around Asia, Europe, and the US. Spent a lot of time in Singapore, Malaysia, Indonesia. And I've also been able to attend conferences around the world. And most of this was working with the Teradata group and Teradata database, but this talk is completely agnostic with regards to database. My college work was economics, and I took some graduate level coursework in econometrics, which was data science back in the day, back in 1984. It's been around for a while. We just called it by different names. So it's not a new concept. What's new is the amount of computing power we have to throw at it. And I'm not a data scientist. I really don't have the graduate degree in math. Talking to my wife this morning, she's like, well, data science is a made up, title. I'm like, well, they all are. So one thing I want to share with you was when I started working, actually, I worked for a large hotel chain. And one of my first data projects was to bring in all the point of sale data from all the restaurants, 3 hotels around the corporate headquarters. And I brought it all in. I was very excited, had it in a database, could show how many coffees we sold, how much orange juice. And I showed it to the VP of food and beverage, a German gentleman. And he's like, Andrew, what am I going to do with this data? And I think that's one of the lessons we learned is you've got to prepare use cases. You've got to understand how the data is going to be consumed. Just preparing reports and getting other things is not going to make you a winner in your organization. You've got to think a little forward of how that data is going to be used. So that's just one of the things as we go through, we'll reference that. So a few thoughts. What basically is data science? It's a little nebulous. A lot of people say they are data scientists or in the data science realm. And I kind of break it into like data plumbing. And really data science, where you're actually getting into like some hardcore math and actually working with big data and data sets and making really interesting decisions, or maybe even eking a little bit to artificial intelligence and machine learning. As you get to big data sets, I find a lot of people want to get on projects. They're really more looking at analytics and understanding the data. One thing I say is that you shouldn't be able to do any big data science projects till everybody in your organization who needs to can get a P&L statement printed out in a timely fashion every month. And I would say 50% of all organizations probably fail that basic accounting need, but yet they're looking to go beyond that and do more advanced analytics. I'm like, you need to get your base foundation laid, and then you can build on top of that. But if you have a shaky foundation, adding in additional stuff is going to be a challenge. I'll walk you through a little thoughts on how you become a data scientist and what are the requirements. We'll walk through a few use cases, and then we'll wind up looking at some data science tools. And then at the end, we'll do a question and answer session. Also have a raffle in there. If you want to log on to the one page and enter your information, we'll have a $100 gift card at some point. So that'll be later in the presentation. So let's go on. All right. So this was interesting. I kind of hung it on it. The sexiest job of the 21st century, according to, oh, so yeah, if we want to talk about data science and popular culture, the one thing I would look at is the movie Moneyball. If you haven't seen it, it is probably the best movie about data science and its practical application. And this goes on to, it's Brad Pitt takes over the Oakland A's. It's a true story mostly. So he finds a team, and they're in a cash crunch compared to the Yankees and the Boston Red Sox, who are spending like $100 million. Oakland has like 40 million to spend on their baseball players. And if you watch the movie, and there's some dramatization, but you got the, you've got the old world scouts saying things like, we can't get that pitcher, his girlfriend's ugly. And he's like, why does that matter? And they go, well, he doesn't have self-confidence. So Brad Pitt thinks that's silly, and let's go and look at the numbers. So he gets Jonah Hill. And when I talked to my wife about this, I said, well, yeah, I'm sexy like Brad Pitt. And she goes, no, you're probably more sexy like Jonah Hill. So, and this really is a data science guy. If you look at this, he's the guy that does all the numbers. He's sitting on the computer, and Brad Pitt hires Jonah Hill away from the Cleveland Indians to do his data crunching in Oakland. And what happens is they win playoff games for like a quarter of the cost that the Yankees and the Red Sox do. So they look at players as an asset, crunch all the numbers, see where they fit in, and then go from them for that. So that's why the Oakland A's were very good. So Brad Pitt's not a data scientist, but he's an important guy in this story. Anytime I work on a big data science project, I typically have, and I call it, they're mostly MBAs, but I typically have somebody who's inside the company who understands the function, understands everything that's going on with there. Because when we start to look at data and pulling out data, I need somebody who can really understand the internals of the business, and what is important and what's not important. So this is Brad Pitt's character in the movie, and Jonah Hill's, I guess, would be my character. So maybe not as sexy, but if you're interested in the article, I'll put the link for it here. I'm not sure if it's quite right that it's the sexiest job. It's kind of hard to define what actually a data scientist is, but that's what the Harvard Business Review, and hard to see that they could get it wrong. So what does a data scientist do? He does experiments with data, right? So you're going to look at all the data you have and say, hey, how can I improve my outcome of my credit card mailer? How can I reduce my churn in mobile phone sales, right? Verizon's very interested in. If you're an airline, maybe how do I reduce my fuel cost on my flight? If you look at airlines, they are super invested in reducing fuel costs, right? So that is a thing that they're very interested. So you would gather all the data, put it together, and then run experiments, and then evaluate the results and try to disprove it. So these are the kind of things we can do as data scientists. So it's exciting, it's interesting, and can be very profitable for your corporation. If you're not lined up with this, if you don't have a correct infrastructure set up so you can start looking at all that data and pull it in, then you're probably going to be, it's going to be problematic to do that. But if you can do it, you can save the company a lot of money. So we're going to mix our little data together. Now, what are the requirements to be a data scientist? And again, since this is an arbitrary designation of what a data scientist is, I went out to the web researching this, and I got 11 requirements. And the first one is going to be math, and particularly statistics. If you think you want to be a data scientist, you probably should have statistics courses and understand the math. And the second one is going to be some familiarity with programming. SQL, Python are right now, when we look at it, are all big elements in data scientists. But I think the other important thing is just a curiosity, wanting to solve problems, right? You want to look in there and not only solve the problems, but once you solve the problem, can I make it a little better? So the data scientists I know are typically not happy if they come up with a 2 or 3% improvement in a solution. They want to go back and see if they can get another 1 or 2%. It gets harder as you improve solutions. But sometimes that's a secret sauce. Once you get up above your competitors, then the field's open to you because now you're winning all the time because you're a little better. So here are the 11 requirements, and I'm not going to read them all. But if I look at the ones I think are important, data science is a team sport, but again, it's mathematics and creativity and innovation. Now, there's a little story. I went to a data science class here in Portland, and there were 40 of us. And the instructor handed us a data set the week before the class we could look at. It was all the stock ticker prices from 1970 to now. And when we got in the class the first day, he's like, okay, identify what group you want to be in. Are you, super knowledgeable? And it was 1 to 5 where you sat in the data science spectrum. And we self-divided into teams. And what's the first thing everybody did? Well, they started, writing Python scripts to throw all the data in R and trying to get results of it. I was the only one in there that started asking questions about the data. So is this adjusted for inflation? What about stock splits? What about survivor buys, companies that have gone bankrupt? How is that accounted for? So, and I think what I see a lot in the business world is everybody wants to go in and throw that data right into a database and start running analysis on it, which is usually not a good thing to do. You want to dig into that data. You want to enrich the data. You really want to understand what it actually is. So part of your role as a data scientist, and I mentioned that it's a team sport, you're going to have a lot of people. You're going to have UI people. You might have ethicists if you're in a medical thing. You might have psychologists understanding how people respond to your data. Can be a team sport. It's probably just not you sitting there alone. I mentioned before, I had my buddy, the MBA over there, advising me on what this data is really going to do and how it's going to impact the company. So without all these people, I'm unlikely to get a good result when I view that as achieving the organization's goal. Now, it's not always saving money, but 90% of the time, it's gonna be saving the organization money. So if you look for a really true data scientist, I mean, I've met several of them, but again, they have graduate degrees in math and they want to talk about all these different distributions. And I'm on a lot of lists and I follow them and I can read it. But I don't quite have the desire to go in there and do all the heavy math. So that's why I say I'm not a data scientist. Again, we cover the key characteristics. You're going to really want to solve your problems. You're going to have a deep understanding of the data, and you're going to understand statistics probably at a graduate level. So if I go to the next slide. So I have sort of the Rodney Dangerfield is the anti-data scientist. And I use this, and I call my wife is, she's into HRIS data, but she's not a data scientist. She doesn't like math. I mean, she's a very good data analyst. She lines up all her stuff. And an example I use is when we play blackjack. So if you're at the blackjack table and you are not aware of independent events, if you think where you sit at the blackjack table probably impacts your odds on the game, if you think the fact that the person is drawing too many or too few cards before you, and that impacts your odds of winning, then you're probably not going to be a data scientist. I mean, and there are a ton of good jobs you can be, but data scientist is really not one of them, because you're probably not understanding the statistics and how distributions break down. So again, there's no shame in not being it. I have had some discussions at these data science conferences. We tend to go out on the various towns, and wind up in the street at 2 a.m. discussing data science. And I had a gentleman who called himself a data scientist and was insisting that if I flipped the coin 10 times and it came up heads every time, the next time it was more or less likely to turn up heads. Of course, the coin doesn't know that it's come up heads the last 10 times, assuming it's a fair coin. So it would have no knowledge that the next time it should turn up heads or tails, so it'd still be 50-50. So again, no shame in not being a data scientist, but if you don't have these beliefs, it's probably not a field you want to go for, and there's plenty of other fields to do. If we look forward right now, we've had this thought where a lot of people are leaving data science, their jobs. And a lot of this is all the sexiness that the Harvard Business Review said on it, it's really not that sexy. A lot of data scientists are being cramped into what I call data plumbing. And again, a lot of these organizations don't have big data science group. It's not like Google where you're just doing data science, or LinkedIn or something. Most organizations are significantly smaller, but they still need to do a little data science. And again, that mix between analytics and data science is it's not a quantum leap. It's more a slope that we take. We go from analytics into sort of data science. An example I'll give of that is a friend of mine who's runs a manufacturing company came to me with a problem of optimizing his production runs. They have 10 separate products they produce, and it takes them 100 hours to switch the lines over from one to another. So we had a discussion about how to predict using your past orders data, predict how many of these items you're going to sell, what the cost is of carrying that inventory, and then how to minimize the machine switchover without getting burdened with too much inventory. So, maybe not a data science, but that is something that would be very interesting. And this is a small company. They're $100 million a year, so they're not very big, but they could still optimize, and probably, I figured they could improve their bottom line by $1 million, which would be 1% of revenue. Probably, if you looked at it, assuming they made 10%, would be a 10% bump in revenue, which would be quite large. Okay, we want to have integrity with our data. It's pretty common. I've worked on some projects. When I was in college, taking the econometrics course, a professor, I went to the University of Colorado, and he was approached by the ski industry and said they want to do a study on the economic impact of the ski industry for the Colorado economy. As it was sponsored by the ski industry, the background of the study, or the assumptions of the study, were made to be very favorable. It would not be possible for this to not come out, that it was a very huge success. And the professor said at the time that he would not do this study unless he could have his own assumptions of how to begin. And the ski industry said, thank you very much, we're not going to pay for that. There's some interesting books, Bad Science and Bad Medicine, that talk about how various industries, sort of use data scientists. I just saw a recent article about data charlatans, about you can use the data to present any viewpoint. So if you're really trying to optimize your organization, you want to be careful that we really have faith in the data. We want to be proactive about double checking our data sources. And if we're pulling data from one system to another, do we have automated checks in place? If we're doing data science experiments, are we checking them independently? So we're not just doing the same code that we ran to get our results and then say, does it agree with the code? But let's say we're running something for oil change centers in your country, and we decided that this should improve whatever tweak I'm going to do. I'll put out in 100 stores in different areas, and it should improve their revenue by X amount. Well, you do that for a year, you go back and you actually look at the revenue, and did those stores all improve by the same amount that I thought it would do based on that experiment? Because that would tell you, that would be independent. They would publish your results and you could see it independent from your experiment of swapping out the oil filters or whatever. But we see here the pointing here, boss on Dilbert, saying he just wants to adjust the data. And it's funny, but I've seen this. I've seen people come back into stuff like, well, what do we need to make this work? Well, we need this to be, okay, so that's gonna be, we take 100 support calls a month on that. And I'm like, we don't take 100 support calls and each one's $25. I'm like, that, you're just making that up. And yes, that is common. So we do want to be careful that we have data integrity. So if we look at our hierarchies, how do we get to have a data science environment? We got to first come to a data architecture, right? So what do we mean by data architecture? I want to have a scalable, powerful data processing platform at the core of this, right? So I have to have something that I can bring my data in, load it up, and run experiments at the scale that I want to run them. And some of these can be quite intense. If you're looking at very complex stuff, we had one thing with a big bank in Southeast Asia that ran for a month. And then eventually after a year and a half, we were able to get it to run in 8 hours. But it chewed up a lot of processing power. At this level, data architecture, I would also have my master data management, my loops coming back and forth. And if you ever looked at some of these documents that have how data flows within an organization, and you have it spread over 8 pages on the wall, and you have 50 interfaces and things going in loops of this feeds this, feeds this, feeds this. That's a very difficult data architecture to do anything within a data science. What ideally you'd like is like maybe a big hub and spoke with some variations on it. You have one big center spot that collects everything, and interfaces being read back and forth between that and each of the other databases or applications. Now it's difficult, but I think that is the model you want to go for. The more complex you have, the more steps the data has to go through before it's consumed by anyone. It's going to be very difficult. I worked for a government agency, and we just couldn't make any sense out of the data. I mean, it ran forever. We couldn't see half of it. Nobody knew what this was. Had a lot of difficult problems with it. So at that point, we want to, now we've understand how the data, now we want to move the data around or transform it or expand it, and we want to cleanse the data. Now there's this big concept of a data lake. It's also morphed into a lot of a data swamp, where you just say, hey, let's bring this data in here in case we need it, right? So I don't need to curate it, or the other term is schema on read. This would be a lot cheaper, because actually it doesn't cost me much to have a programmer bring in data to this level. Where I spend all the time is coming to an understanding of what this data means, and then tying the data out, and then automating the validation that the two systems are the same. What is null here? What does this title mean? Why do we have 8 titles for this person? So this is where the business people really spend a lot of time in cleaning it. Now, I'm okay with data lakes because I understand it, but I prefer the term data reservoir. So that means we've kind of processed it a little bit. We've looked for problems, especially when you bring in IoT things or semi-structured data. You got to have an understanding that it all matches and it's all there. You may just want to bring it in this data lake because it's cheap. And we did with a lot of people who worked with big Hadoop clusters, and they brought all this data in and they kept it for years, and now it's meaningless because, well, this doesn't agree with this. This is blank in this spot. You know, these date formats are wrong. We look at it and we, can you cleanse this? And it's like, well, yeah, it'd be $1 million because we got to look at all these different things. And I go, oh, it's not worth it. So you paid all that money to bring that data into the data lake. Don't fall into the assumption that just dumping raw data into your data lake is going to help. You got to at least take a pass at curating that the first time, because the guy 5 years down the road, when now discovers that that data is going to be used for something, will be a lot happier with you. And it might be you. And at the top, we have data science. And that's, now you've got all the data in, you've got a architecture that will support running most of your experiments at scale. And you can actually do this. If you don't have, you know, data architecture and your data in a reasonably clean state, you're not going to be drawing any conclusions from your data science. All right, so I come up with a couple real world use cases and one I made up. This is a ship engine for Maersk. You know, those big container ships that hold thousands of those containers have this engine. So they they went out and did this data science project for predictive failure of cylinders on their boats. And here's the cylinder. So you see they're pretty large. I guess it's the piston. So what happens is if one of these fails at sea, it becomes a whole logistical nightmare, right? I mean, I assume they make it to the next port with their engines, or they have half engines, but it's very expensive to replace. They typically don't have these just hanging about. They've got to fly them in. It's expensive. So they put out a challenge to these 4 teams to see who could predict when the pistons would fail. And the winning team took a couple things into account that the other ones didn't. The 3 of the team, you know, focused on vibration, temperature, and other signals from the hardware. The 4th team and the winning team took into ocean currents, length of time that the piston's been in there, temperature, vibration, where the piston was manufactured, and where it was installed. And they managed to considerably improve the predictive ability by like 80% over the other teams. So even though they didn't get to 100%, which would be really difficult, they had a significant improvement because you don't want to replace them too soon, because I think it's like $10 million to replace one of those pistons. And they, you don't want to replace them too late because then it would get to be a real challenge. The other one is on bank loan approvals. And this was a bank in Australia that worked with these bank loans. And what they found out is these people that would, you know, basically quit the bank loan. So they had all this stuff in here. They ran these use cases and they found, you know, the number of customer service complaints, any letters written, any other things. They could predict when a customer would quit the bank. So they had the use cases, they had the data science. It was really good predictive model. Why did it fail? Well, it failed because they found out they couldn't remedy the situation. So they knew that the customer was going to leave, but by the point they knew, they couldn't offer them anything or make them happy. So the customers wound up leaving anyway, or I assume they could have, but they didn't want to spend the $5,000 to do that. Now, the made up one I have is, again, go back to my wife. She orders a lot of shoes off Zappos and returns a lot of shoes. because of her foot size, they don't typically fit. So I've often wondered, and I'm sure they're looking at this, is to understand the characteristics of the shoes that somebody would like, width, length, color, other things, and steer them more towards shoes that they think would be a match for them. And I'm sure Zappos is working on this because, I return probably 10 pairs of shoes for every one that get bought. So here's a use case that I think you could see for that organization would make a lot of sense and probably be very, have a very quick payback. Here's another question I had, and we actually worked on this. I'm working for an organization and they said, Andrew, how many employees do we have? And, my stock quote when somebody asks me something is 6 months and $60,000 to get them to go away, but they really wanted this. And this was 6 months. I mean, we're all employees, so we really didn't allocate expenses for it, but it was probably around $60,000. Employees, I guess, are not simple because there's not a common understanding of what an employee is. Budget might treat them as full-time equivalents, right? HR treats them as individuals that have worked over so much. Then you have people on short-term disability, long-term disability, contractors. So each department, whether it be benefits, HR, the actual departments that have them, have a slightly different view of what an employee is. So when we actually did that human capital management page, it got into a lot of little differences that you would answer that seemingly simple question of how many employees do I have? And again, there's not one answer for it. And if you built out a simple answer, which my first take on that was, well, we'll go into the Oracle table and we'll just count up the number of employees who have a status of active. And they're like, oh, no, that doesn't work. We need this, this, and this. So you find out, even though it's a simple question, you're going to have really different responses. So that is, and there will be a lot for that I think you would have to do with these projects. All right. I see I have a chat thing here. I'm going to put out my survey here. Hold 1 second. Okay, I've got a little quick link to this Google form. If you put your information in a few minutes, I'll draw for a $100 gift card to Amazon. I'll send it to you by email. If you don't want to, no big deal. But if you send your information in there and let me know, I will contact you at the end of the session. I'll pick someone. All right. So I kind of use the thing of the 4 blind men and the elephant. They're all looking at the elephant and identifying it as different parts. Data science is kind of the same way. We're looking at this and we're all seeing it differently. We're not looking at it as a whole. So that's kind of why I picked that. So when I go to these data science conferences, I tend to find that we have a lot of different products and they change a lot. So if you go, hold on 1 second, please. Shut the door. Sorry, somebody's vacuuming upstairs. I had to get the door shut. If you look at there's always 30 products up here. And if you look at R, C++, Python, they're always going to be here. But the platforms and the data ingestions too all tend to change slightly. And what you see every year is 3 or 4 come in and 3 or 4 go out. However, when we talk about the whole data architecture level in there, the key ones will be around forever. But at the point to get your data architecture put together, you're gonna have to make a pick.
Andrew, I think we're losing your.
Right?
You're not coming clear. I think we lost your audio for just a second.
Okay, do you hear me now?
I think so. It's very, sounds like you're underwater.
Sorry about that.
Oh, that's better. That's better. Sorry to interrupt.
Okay, move. No, thank you very much. I appreciate that. So the thing is, you have to stay current with your tool sets, and you want to keep looking at those to make sure that that's correct. So, okay. All right. And the kind of last bit I'm going to get here is AI and machine learning. Again, I talked about this a little bit, that we want to get into this because this is the exciting bit when we get this. We're going to have stuff that will come. Oh, 15 responses. All right. Sorry. All right, I'm going to close out the survey in 2 minutes. So if you want to respond, you should respond here soon. Sorry about that. And again, if we talk about the hierarchies, we have data, we have the old hierarchy form I showed you. But right in the middle of that, we're going to have AI machine learning on the top. So we have this. And then how do we do that? Do not see survey. Hold on 1 second. I got a Q&A here. Okay, I'm going to send out in chat again. I'm going to send out the survey. Michael, you should see it in the chat window. It's a forms.gle and it's got some long address for the Google Forms. So now I kind of have the AI machine learning on the top of the pyramid, because I think really that's where people want to get to in the longer term. So again, I just want to end with sort of this concept of data science is data research and development. We got to be looking, we got to be willing to fail. I mean, too often I've been on projects where people have wanted it to succeed, even though it didn't make any sense. And people have pride in there, where what we really want to do is we want to have our best thing forward. So we don't want to necessarily say that I won this and this was right. We want to say this worked best for us. So if we look on this, whether it be you know, selling cell phone minutes in Indonesia or whatever. You want to be able to do it quickly. Sorry, I'm just trying to pick the winner for the. Yeah, excuse me. And the winner will be Nikki Barnes. So Nikki Barnes, Ampora State University. Okay, can you hear me? Again, failure is okay. We're good having failure. We are, it's not a problem. We probably fail 3 out of 4 times. And part of it is measuring what success. We don't want to put a poor data science solution in. We really want it to win. And a lot of times that one winner can be so powerful that it's good. But if you put in a lot of bad solutions, you get bad press, people don't trust it, or you put in solutions that actually cost the organization money. And again, I want to put that if you're pushing in stuff that is not really beneficial to the company, you're going to cause a net loss to the organization. You're going to cause things to fail, and you're not going to make people happy. And then your next project, even if it is a winner, is not going to get buy-in. So that's my presentation. Thanks you all for attending. I got my contact information here, and we can open up the Q&A period right now if anybody has questions. Michael, I hope I answered your question. Are there any other questions? Can you hear me?
Oh, we had something just pop up.
Okay, open. I see I have an open question. How do you choose a tool? Okay, so Mr. Anonymous Attendee, it's a good question. When we talk about technology, when I look at something, we'll look at what your current stack is involved and what your skill set is involved. There's this concept of tech debt. Every time you add a new application, a new product to an organization, you incur tech debt, right? Because now you have to have people service, you have to license it, even if it's on a cloud or whatever. You've now got all this infrastructure in place to do it. So if I come into a new organization, I'll look at the tools already in place. And let's say they're Informatica shop. We would probably look for an Informatica tool because they already have this relationship and they work with them. If it's a new greenfield opportunity, we would interview the people, talk to people, what is their really goals? Is it cost? Is it performance? Is it whatever? And then we would pick the tool that best worked with that. Rokas says R against Python. I usually would use them together. You know, I use R to kind of do the math in that, and Python to sort of put the data in there into a system. So I don't see R and Python as necessarily competing. I see them kind of working together. So recommendations for books. The book I'm reading is not By the Numbers, which shows you how, as an actual, it's more analysis of how to display things meaningful with pictures. It's hard to know. The thing I would do is I would go on to you know, one of the online learning sites and get my statistics course done. I don't know any book. I would suggest an online learning course for statistics to get you set up. I can't think of any books right off the top of my head. I mean, I like Bad Science, Bad Data. There's also an interesting book is Super Forecasters, which just deals with how like everyday people could be the experts in forecasting and how they go through forecasting. And there's also the Freakonomics series, which I think deals a lot with how that works. I think my time is up though. So
You're
thank you all
okay.
very much.
If you need to answer any more questions, you're okay, but I think that might have been it.
It is. Well, thank you all very much.
Great. Thank you so much, Andrew. Enjoyed the presentation. And we will have a brief intermission and get started again at the top of the hour.